check, you can hear 100% infill. Good screen here. This is also on island. I mean, can you even see it 3D printed? Oh no, even play around. It's very nice. So we are in the lab. 40mm cube. Whoa. Be mine. All our different materials. How do you guys like this? I think we are live. Hey everyone. So, a lot of new stuff today. So there's a lot of things that I need to check. How is the sound? I have a couple of good news. But first, sound, video, everything's good. Yeah, the logo is awesome, right? What do you think about the logo? PrintBuster logo. Looks good. Okay, great. Is that better? Is that better than Tuesday? 720p now? Let me check. Yeah, 720p. So the quality I have here, you should have the same. Sound is good. Perfect. Check this. No more wireless internet. I'm finally connected via the wire. So hopefully, I just checked the internet is very good. Now the issue is when I use the VPN, it's still not that good. But if I don't have the VPN, then it's very good. Yeah. Finally, the cable plus the adapter. And now I have the camera. I missed that camera. Before we were, let me show you. Before it was that one, right? But now we're coming back to our camera. Upgrade. Better background. And there's one more thing. One more thing I want to show you. Check this. I hope it's going to work. Let me check. How awesome is this? There's a couple of things I need to change. Like here, I want to put 9 p.m. I think American people, they don't really use the, all the numbers after 12, 13, 14, 15, somehow they don't use that way. So I will change this. But what do you think? And then if I use this, yeah. Oh, I need to change a little bit. I wanted it to cover the social media properly. Yeah, maybe I need to do a few more changes. But we are evolving. Slowly, we are getting things better. So who do we have here? Bear Squad, thank you. Welcome to our first PrintBusters show episode. Stephen Pools, Non-Fam, Zombie. Oh, by the way, I wanted to prepare all of this, and I forgot to send the invitation for the stream. So, Zombie, do you think Zombie is here, right? Yeah. Do you think you can help me to put an announcement in on Discord, and then I will put the one on Twitter? Because I forgot. Yeah, I forgot. I wanted to make sure we have the internet, the overlay. Did you see also the intro? We have a new. We are going to make it animated, but that's a great upgrade compared to before. And let me put that. So let me try. If I put, let me try to put the VPN, and then you can let me know. Zombies everywhere. Yeah, I agree. And okay, so now I have the VPN on. Let me know if you have dropped in quality. Oh yeah, you should have. I already see the alarm on StreamYard. So let me know. I guess now the quality is much worse because I'm using the VPN. Yeah. Okay, so let me put back without the VPN, and then we should be good. I just need a VPN just to get the YouTube link and to post on Twitter. And once I've done that, then we can go back without. And then I will solve this. We have it. I mean, without the VPN is good. Now I just need to solve with the VPN. So let me get that link and let me just post on Twitter that that we're live. We are live. Okay. And now let me remove my VPN, and then it should be good again. Let me try. Remove. Okay. And now it's gonna get better. You should. Just wait a little bit. Yeah, so is Mark and Draka here? Wait. It should come back. It's coming back, but very slowly. Okay, now it's back. Okay, so now it's without VPN, and it should be much better. One without VPN that just handles the stream, and a second one which you use during the stream, and you send it monitor signal to the other PC. Oh, that's a good idea. Oh yeah, that's a very good idea. You should either have two PCs or a PC plus iPad. Oh yeah. Yes, good idea, Griff. Thank you. I will do that. So now it's back, right? So did Zombie post on Discord? Because I also need the VPN for Discord. But if I put back the VPN, then it's gonna drop. Let me check. Yeah, I don't have access, so I don't know. I don't know if he put it or not. But it's not extremely good. I mean, I thought. Let me do a test again. I thought if with the cable it should be much better, but I'm not that good. It's not very good. I don't have VPN. I don't have anything. Is it because it's too awesome now? There's too much awesomeness on the stream. Let me check. So I will change one more thing. Okay, good. Now all the quality should be there. Now we're gonna start the stream, and then we're gonna see if it's stable, because that's the most important. Because now we have good internet, but now it has to be good and stable. Okay. Francis, thank you for coming. Builders Mark, get some Starlink. Yeah, I'm not sure we're gonna have Starlink in China, but let's see. David M. Now it's Abdullah. Who else do we have? Hybrid Robotic, thank you for joining. One Raz. Yeah, so I was asking, is Mark and Draka here? Because if he's here, then no need to do the giveaway. I will just ask him. What spool he wants. Yeah, it's all good. Yeah, it should be good now. Okay. Let me put this. Okay. I think it's better like this, right? Oh, Mark is here. Sorry, everyone. By the way, maybe it's better if I start the giveaway, right? So Let me start. I'm awesome. Okay, there you go. 8 entries so far. Yeah. We should do that, Santiago. I will give a spool to Mark Andraka just to make sure he doesn't enter the giveaway, and then we can do the giveaway with other people. We have the Mark Andraka giveaway and the other people giveaway. Art March Animation, thank you for coming. And Art March Animation, there is for other people, Art March Animation made some nice animation, which I will also add. I don't think I have uploaded them yet. Let me check. Yeah, I don't have them yet, but there is some nice small animation that can pop up. But slowly, like we said, right? We slowly improve our stream. So, what is PrintBusters? I know most of you know already what is PrintBusters, but I want to explain a little bit more the concept, because maybe the concept is going to evolve a little bit in the next few weeks until we find, a good concept. Oh, by the way, did you check? Someone didn't really like the lockdown. Didn't really appreciate the lockdown. Sorry, plans. So yeah, PrintBusters for me, before it was like you take a common knowledge from the 3D printing community, and then if you think that knowledge is not correct, or it's not it's not explained very well, then that becomes a PrintBuster topic, and then we try to dive into that topic. We try to challenge that explanation. So that was how we started, and we started with warping, if you remember well, right? There is a common knowledge about what is warping, and then we went and then we challenged that knowledge, and then we had the flow calibration, and then we have the food safety. Now I want to remix a little bit. It's similar, but now the idea of PrintBusters is to take a topic that you don't have enough knowledge. You don't have access to a lot of knowledge on the internet, right? You don't have papers. You don't have you don't have articles. You don't have any videos. You don't have any content basically that explain that topic. And then PrintBusters will take that topic, and then we will dissect that topic, and then we will try to get some knowledge out of this. So PrintBusters is basically the place where, if there is nowhere else that you can learn about it, then we just gather our brains, and then we just try to figure out together how it's working, because there's no other content. So that would be the idea. So it's like PrintBuster, and then we can have something like take a deep dive into 3D printing. Yeah, that's not bad actually. Like, we should have, let me write that down. Take a deep dive into 3D printing. Something like this. Something like this. Take a deep dive into 3D printing. What do you think? Like the kind of slogan. What do you guys think about this? Stupid myth, ABS is stronger than PLA, when in reality it's the opposite. Go with that one. Yeah, depending on what type of strength, right? So in PrintBusters, vocabulary is very important. I was watching a stream, I think it was yesterday or the day before yesterday, from who was the name again? Crunchy 3D. Let me check. It was on Twitch. Oh yeah, but I don't have access to Twitch because I don't have VPN. Krusty 3D or something like this. And he was also like this. Like every word that people were using, he wanted to make sure that they use the right word, like right definition. And I think if we want to have PrintBuster works well, then we need to define and use proper vocabulary. Like I did a small stream on Discord where I was explaining some 3D printing phenomenon, right? And I was explaining oozing, stringing, and stuff. And for me, when I use the vocabulary, oozing, stringing, spider webs that you have, they are all different for me. I know online when you look for oozing and stringing or the spider webs, they're basically the same. But why I define them differently? Because the root cause of what is causing all of these issues are different. So if you have an oozing problem, then you will solve it like this. If you have a stringing problem, then you will solve it like this. The same as clogging and jamming. For me, it's different. Clogging, you solve it this way. Jamming, you solve it this way. So, of course, in terms of, like dictionary definition, they might be very similar, right? But in PrintBusters, we try to put some definitions so that it's easier to communicate and it's easier to troubleshoot. Good luck with melty PLA, then summer when the temperature is above 45 degrees. Flex isn't strength, it's flex. PLA is stronger. Yeah, so it looks like someone has started a debate already between ABS and PLA. So every time you talk about strength, try to define that. For example, Tom Lamourin, you say PLA is stronger. You have to define what type of strength. Are you talking about its impact strength? Are you talking about the tensor strength? Are you talking about the shear strength? Are you talking about the torque strength? Or whatever other type of strength? You have to define. Because yes, PLA is stronger for some type of, depending on what test you're doing, PLA will perform better than ABS. But for all the tests, ABS will perform better than PLA. So every time when there is a debate around something, the most important is to define, what you're talking about. You define your words. Otherwise, the debate goes nowhere. Someone say PTG is stronger. No, PLA is stronger. No, ABS is stronger. And then start to argue around that. But it doesn't make sense if nobody defined properly. Because sometimes there's a debate between two persons, but if they start to define what they mean, well, it ends up being the same, right? So that's very important. And in PrintBusters, this is a very important topic. So every time, if you go on our Discord, we have a PrintBuster category, and then I think we have 3 topics at the moment. And every time, at the beginning of a PrintBuster topic, we start by defining properly what everyone is talking about, like what's everyone's vision, and then we ask question first. Okay, this is your vision. So how about this, and then this, and how do you define this? So we spend time understanding first what is the vision from that particular person, and then we try to explain our vision. And once this is very well defined, then we start to debate around different points that are not the same. Robot voice. Okay, so it's not stable, right? Please name one point on the 3D printer that needs impact. I was watching a CNC Kitchen video and they were talking about a modulus. Thought about your chart. Strength is a too broad term. Exactly, destruction. We have to define that. Okay, so the internet is not that good, no? It's dropping again. And you know what? I'm going. We have someone in the office that is responsible of internet, right? What I'm gonna do is I will take a selfie of us streaming, and then I'm going to send to him. Then we're gonna do a sad face, telling him we need a better internet. Let me selfie. Okay, let's send him this picture and ask him to get a better internet. We don't have a good enough internet. We need very, very high speed. Because if we start to deep, like what if we are running some I don't know, some simulation online. There is actually, you know what? There is I forgot this news. There is helio additive. Do you know helio additive? You can check. And so this company is going to come as a guest on PrintBusters. And this company, guess, is doing what? is working on warping. I mean, kind of. It's not exactly warping, but it's working on reducing internal stress during the 3D printing process. Okay, making your prints go as fast as possible, like printing time, optimize printing time for the best quality and strength. And obviously, internal stress is a big part. And they have simulation, they have a lot of things. So all the debates we had on warping, well, we can ask some question there, and we have some charts, and we have some simulation, and we have some awesomeness data. So yeah, just before I forget, so let me send that picture. Okay, we're not happy with internet voice of the Polymaker community on stream. Even with wired internet. Okay. I should put enough pressure to have a good internet next time. If you hit a printer, it hits back. What kind of discussion are you guys talking about? Internet, we have whatever we can find around here to connect to. We need something better. let me take a picture of that. Build the smart. Let me take a picture of that. That's not how science works. Try unclosing your PLA 3D printer or keeping it in a cardboard box in the garage print engineering material. Your PLA printer will last 4 days. Every says PETG, fiber. Hi, IT department. Yeah, exactly. You know, you should take screenshot of the when it's low quality, like very, very bad pixel, and then you should send me a selfie with that. Now we send to them. The Polymaker website has a lot of material data to compare different filaments. They are all different. So if you need a particular properties, you can choose the correct filament. Yes. And that's the reason why I put that on the website, is because, you know, when you want to dive, you know, you're at home and then you want to understand a little bit the difference, then you need to have access to good data. They are not perfect, but they are good enough for you to get an idea. Like we were talking about PLA. Okay, let's do that. Apparently you're talking about a PLA, PTG, ABS, right? And apparently some people are PLA are underrated, and I guess some other are saying is overrated, right? I guess. So let me. Can I share? I should have shared that before. Let's do that. Oh, so the overlay is even when I'm sharing. Is it like this? Yeah. So maybe I will remove the overlay when I'm like this, when I'm sharing. Okay. So let's take a look. Let's take a look. So who is saying what? Comment. Because I've seen some stuff. There is literally 0 part on the 3D printer that has an impact. Heat is the only issue, and through HTPLA we hold heat as well as PTG or ABS. Okay, so I think it was Tom Lamourin, right? That is more towards. Let me check. Oh, 3DQ is here. Strengths can mean many things. Ultimate tensile strength, yield strength, toughness, stiffness. Yes, exactly. So actually 3DQ we're very lucky to have them in the PrintBuster community as well, because they're very smart, and I think they always take a very logical approach, which is very important when you're doing scientific research. Okay, Yeah, I cannot find the I cannot find the specific message. Hi, Robert. Thank you for joining. So look at all of these different feature of filament, whether it's a physical property, whether it's a mechanical property, a thermal property. So ABS, and PLA. Well, another thing, what PLA, right? So I guess you're talking about regular PLA. Again, what is regular PLA? I mean, is Polytera PLA considered as a regular PLA? You see how what is PrintBusters? Because if you talk about PLA, what is PLA? There's many different grade, right? Even if we don't compound our specific formula, there might be even the grade itself, right, are different. So which PLA should we took? Even polylite PLA? Is that what you consider as a regular PLA? Yeah, I know. Can you at least read? Is the quality good enough so that you can read what I'm sharing? Can you read the data, or the quality is too bad? When I'm sharing the graph, can you see the data? Can you read what is written? Like 3.25 Sharpie impact strength, polylite PLA. Okay, it's readable. Okay, great. So let's take polylite PLA, and then ABS, right? Okay, so that's the Sharpie impact strength. Okay, so we agree in that specific case, ABS is better than polylite PLA. But then what if we take I don't know, how about PLA Pro? Okay, how about now? Who is better, ABS or PLA? And then let's take an even bigger. How about now? Is it PLA or ABS? PLA plus is not HTPLA generally. What is PLA plus? It's the same. Tom Lamourine, you have to define properly. Is Polymax PLA or PLA plus? Is our Polylite PLA or PLA plus? Because if you consider PLA as what? So, and that's the basis of when you have a debate. Because if two people are talking about two different things, how do you even want to find, like, we cannot have a discussion if we don't define properly. And that's what's happening in 3D printing, which sometimes is fine. People don't want to go that deep, right? They don't really care about it. As long as it's working, as long as they click print and it's working, whether it's PLA, PLA plus, PLA, whatever, super mega plus, they don't care if it's working. But that's not what we're doing here. Here we're defining things. You have too many products. Yeah, that's just the beginning. Maybe you could add a color coding to the graph that correspond to the overall material type. PLA blue, ABS red. Oh, yeah, okay. Yeah, that's all. We could do that. That's a good idea. So I think, Mark, what you're referring to is depending on the color, the mechanical property may be different, right? It's a little bit too much work for us to test all the colors, but we can definitely write which particular color we used in order to have that data. And then we take this as a representation of the whole product. So that's a good point. It's tough to compare because each company have their own recipes. Yes, exactly. Tom Lamourine, no, basic PLA is lower PLA, like 560 resin or something. True HTPLA is 850 or 870, okay? PLA plus just mean base PLA with additive. Yeah, I agree. So Tom Lamourine, so you define PLA plus as a PLA and then you compound it with some additive, right? And you define basic PLA is lower PLA, like 560 resin or something. Okay. Again, depending on the resin, also you have big difference. Like our Poilite PLA, check out the modulus of our regular PLA. But I'm clicking on the wrong one, sorry. So if you check, let me select all our PLA. Check this one. Compared to Poilite PLA CF, because Poilite PLA CF is also a PLA, but a different formula for the what we call base PLA, and the other base PLA is even stiffer than that one, even though that one has CF inside. I'm still waiting for the recyclable chart. What was that again? Bear Squad? Do you mean like the recyclability of each material, like the index, whether it's 1, 2, 3, 4, 5, 6, or 7? Protopasta HTPLA can hold up to 140 degrees once heat treated. I don't know if you have an equivalent. We don't have. Yes. Okay. Yeah. So I can tell you. I think all the PLA, I think they are 7. So the worst one. I mean, I don't have Google. All the PLA are 7. PTG is also 7. So this is also something. This might be a small PrintBuster topic, right? A lot of people compare PTG with PT. They say I print with PTG because I can recycle, but PT and PTG, they're different. And actually, you know, they're completely different. PTG, the recycling index is 7. PT is 1. Okay, so PT, yes, this is the most mature recycling industry, but PTG, no. So PLA 7, PTG 7, ABS. I'm not sure. Maybe ABS, maybe 3 or 4. Maybe you can check. I don't have Google because I cannot use the VPN. Otherwise, I'm gonna drop the stream. But you can try. I mean, you just have to Google it. Nylon, I think is should be 7. TPU, I'm not sure. PC, I think is I don't know actually. For the rest, maybe I don't know. I cannot check. But I can put that. Let me take some note. I have something to take some note. Maybe I take note here. Let me put here. Where's my? There you go. So some stuff that you would like to add. The first one was the color name, right? Color used for the test. The second one is the recyclable or the recycled index, I guess. Is there anything else? Do you think that would be easier? ABS is 7. Yeah, so apparently most of them is 7, right? So not very good. I think towards the top you have PT. I think you have PP, PS. Yeah, something like this. Okay. So yeah, it's a little bit annoying because I cannot even use Discord because I don't have. Let me try again. Yeah, I cannot have access to this one. So let me just give you a summary. Let me just give you a summary of, because these 3 topics, the warping, the flow calibration, and the food safety, we've been talking about it for a few weeks now. Maybe food safety was the newest one. Yeah, PP is good. So let me try to summarize where we are at for each of the topic. And for that, let me try to start the VPN again. So it might the internet might drop a little bit, but hopefully you can still hear, which is the most important. And then I will give you a summary of where we are at for all the different topics, and then we can start to define which part of the topics we still need to investigate. I was actually saying it would be nice to be able to track the material selected when you change the test that is being used. Figured color would allow for that. Not worried about the color filament. Oh, what? I was actually saying it would be nice to be able to track the materials selected when you change the test that is being used. Oh, okay. So you mean when you choose different materials? Let me try to share again. So what you're suggesting is when you choose different materials. So let's say PLA Pro and Polytera PLA Plus. So okay, so PLA Pro is on the left, and Polytera PLA Plus is on the right. And then sometime if you go and change, then they will switch position, right? Because it's always by increasing number, by decreasing number, right, from left to right. And sometimes they switch. So what you're saying is each material should have a different color, so that when you change, then you can spot where it goes where, right? Okay, I understand. I got it. I have real life to deal with. Gotta go. You all have fun. Thank you, Tom Lamarine. Thank you for joining. Yeah, I know. It's because of the lockdown, Kenneth. So let me do the summary. And of course, Discord is doing their update. Check this. So, and with our internet speed, then this update is gonna take forever. So let me just summarize orally, and then once it's updated, whenever, yeah, of course it's updating now. When we have the worst internet and when we're in the middle of the stream, and then choose to update our Discord, right? So warping, where we are at in warping. In warping, we have two different theory, right? The first one is we call this the elastic shrinkage theory, ES. That's how we call it on Discord. And the other one is the thermal shrinkage theory, right? TS. So we have these two theory. In my opinion, the elastic shrinkage theory is well explained. And actually, a very few people has challenged that theory. Challenge meaning there is part of the theory that doesn't make sense. And we need to dive more into it to see if it makes sense. You know, like where the stress come from, or how to get rid of the stress, or this kind of thing. But that's just my opinion for the elastic shrinkage theory. And then the thermal shrinkage theory, in my opinion, is not very well explained. There's a lot of part that doesn't make sense. I think Grieth has made a theory that makes more sense. I'm not too sure whether it's the reality, but at least, you know, from a logical point of view, it's quite logical. But that's not what most of the people think about the thermal theory. That's I think a sub theory of that thermal shrinkage. And the other sub theory is really I don't know. Nobody has really made a great writing or even a video that would explain properly what's happening. But in any case, we have two different theory, right? How many updates is gonna? 10 updates. Okay. Yeah, it's going to take forever. Now the question is this. What we're trying to answer is, the first question is we need to make that thermal shrinkage theory better, more logical, more detail. You know, when we ask question, we should answer properly. For example, in the thermal shrinkage theory, why two materials that has the same coefficient of thermal expansion, why would they warp differently? If it's about the thermal shrinkage, right? For example, PLA and PC has the same coefficient of thermal expansion. Why would they, like PC warps much more than PLA? There is one kind of explanation on Discord which says that the coefficient of thermal expansion, even though it's the same, because of 3D printing, is not the same. I haven't understood exactly, but this I don't remember the name, but this guy is going to try to find some time to explain it a little bit better. But that could be one explanation. Like 3D printing is changing the coefficient of thermal expansion, or in 3D printing, the coefficient of thermal expansion doesn't mean much. So I think that was his explanation. But I want to understand more. Why does it change? Some other people said PC and PLA has the same coefficient of thermal expansion, but they but the TG is different, and you only start to create stress below TG. Okay. So my answer to that was, so that means whatever the printing temperature, it would the amount of stress will be the same, because it's only starting from TG. So if you print at 200, and then the stress will start after it go below 60 for PLA, right? So if you print at 200 or you print at 300, then it's the same, because it only starts after TG. But in reality, actually, I've been the problem is I've done that with I have printer now, so I can do my own test. So I've printed this. The problem is it's in PLA, so it's not very visual. So I'm doing the same test with ASA, but the higher the temperature and the less the warping. With everything else the same, like the bed adhesion is the same, the cooling is the same. Well, everything is the same basically, except the printing temperature. Okay, and the higher the printing temperature and the lower, so this is the highest printing temperature, this is the lowest printing temperature, and the higher the printing temperature and the lower the warping. And for me, this doesn't make sense in the thermal shrinkage theory, but it makes sense in the elastic shrinkage theory. So that's why we need to explain a little bit more what's happening in the thermal shrinkage theory. Some other things in the thermal shrinkage theory that I still don't understand is they are talking about the thermal gradient, right? Because of the heated bed, you have, it's hotter and then it's colder and then it shrinks at a different rate. And then my answer to that is that you don't use a heated bed and you use a very good cooling fan. And then the whole part is basically going to be pretty much at the same temperature everywhere, right? But we all know that if you do that, then it's going to warp like crazy, right? So all of these questions are not very well answered yet. In the thermal shrinkage theory, in the elastic shrinkage theory, we can answer them very well, very logically. But in the thermal shrinkage theory, there is no good answer, in my opinion. So what I would like is, first, I would like more people to challenge the elastic shrinkage theory. Like, there is a lot of, I wrote some document, and then I explained, I did some stream, I did some videos, I did some partnership videos with Sean on explaining all of that. So you should have enough content to try to find points that needs more clarification. So that's on one side. And on the other side, I also want that people spend more time on explaining what's happening for the thermal shrinkage, instead of you have different layer at different temperature, and then because when a material cool down, it shrinks, then it warp, something like this, which is what we have now, right? May I suggest for the website material comparison page, when passing the mouse over the different categories, give a little definition of it. For example, I don't know what modulus is. Yes, Francis. Actually, well, let me remove that. So I will just the Discord is only 5 out of 10. So let's wait. So let me write this down. Actually, I'm working on a card defining test. I'm working on a card, and every time you will click on one, you will have a card with a picture that shows the test. So that should solve that. In the theory, is said enough times, it become accepted as truth. Maybe it can be FAQ category. Hey, everything plus ultra. Is that a? It looks like a PLA name. PLA plus ultra. Non-fan. I think it's because of the glass temperature. Cooling window is smaller to let the stress go in ABS. Zombie, nothing. You didn't miss anything. I was just asking if you could, because I don't have access to Discord. I cannot use VPN, and we have some internet problems. So I was just asking if you could put the announcement on Discord that we are live, because I couldn't do it. Okay. Yeah, thank you, Zombie. So that's for the warping, and then after we explain both, the idea is to find, there is three possibility. Possibility number one, the elastic shrinkage is where the warping come from, and it has nothing to do with the thermal shrinkage. Option number two, it has nothing to do with elastic shrinkage. It had all to do with the thermal shrinkage. Option number three, it's a little bit of both. But now the question is, which one is the influence the most? You get what I mean? So, like, for example, if we're talking about the temperature stuff here, what I've shown with this test, even though I need to do more tests, right? That's only 3 cubes. But what I've shown with this result is that the elastic shrinkage is more of a factor than the thermal shrinkage. But that's a very quick one. We need to do much more tests. But that's what we need to do. And in order to explain that, then we need to find points, factors that would influence both of the theory differently. In this case, why I use this is because in one theory, the temperature doesn't really matter. If you increase the temperature or decrease the temperature, it's not gonna affect the thermal shrinkage. But on the elastic theory, it will affect. The higher the temperature, the better. And if people say in the thermal shrinkage theory, the higher the temperature, also the better, then they have to explain why. And if they say, it's because the temperature gradient is bigger, then we go back to the coefficient of thermal expansion. Why PLA and PC has the same coefficient of thermal expansion? So it's we need the thermal shrinkage theory to be rock solid, like the other one. The other one, we have a lot of points, but we've been able to connect them. Why we challenge it is because for me they are pretty much all connected, but we need people to look at this and find the point that are not connected. On the thermal shrinkage theory, so many points are not connected, so it doesn't make sense for me. Maybe you can connect 2 points, but then it disconnects some other point. So we need a better definition. I love all the animals at the back. Yeah, actually, I forgot to put them back. How amazing are this design? Very proud of them. Actually, during the secret stream on Tuesday, we made a stream, right? I mean, it was not supposed to be a stream. I just wanted to test the new layout and stuff, and people were popping up in the chat, and then we ended up doing 1 hour something of discussion, which is the equivalent of a stream. But I've shown the this is my favorite design. Option 3 for me, elastic shrinkage is 60%. Thermal shrinkage is 20% unknown. Unknown things, the rest. Oh, you think there is other theory? You think there is another 20% of something else? That's interesting. Yeah, it's already been 1 hour, but this time I'm not very surprised. I'm not very surprised. Actually, it's less enjoyable when your internet is not very good, and then you see We don't have Google, we don't have Discord, we don't have Reddit, we don't have anything. So it's a little bit less enjoyable. So I definitely felt that 1 hour. Not like last time, right? Last time we were talking about so many things, then I think it was like 2 hours, and I thought it was literally 20 minutes. But this time I felt it a little bit more because it's a little bit less enjoyable when you don't have access to Google. I mean, Google is the answer to everything, right? And Discord and Reddit and YouTube, and then we could watch some creators. But anyway, that's a little bit of a summary for the warping concept or topic. Let me put back my my beautiful overlay. So you can jump on Discord and continue that topic. Okay, there is discussion going on, and then during the stream I will show all the test results. I'm still working on testing these with ASA. Oh, looks like Discord is coming. So I'm still working with these on ASA, and if any of you are doing some, I need to log in back and stuff. Let me log in again. I think Joe, the 3D print professor, is doing some tests. I think Igor from MyTechFun is doing some tests. I think Sean has done some tests. Yeah, of course, it's not working. Two-step authentication, right? Okay. Gris, I will have 3D printer, but it won't be in the background. It will be like a video here, because my 3D printer are on my desk, because I don't like to stand up, go and check the 3D printer, and then come back. I like to have everything really near me. Astrium rover. I'm using Astrium. So let me change the banner a little bit, and then let me share this. Can I share? Yeah, so that means I need to remove the PrintBuster stuff again. Yeah, it's okay. I can leave it. Enjoy the logo a little bit. So you will find it here, PrintBuster topics, right? And then you will find the different topic here, and then that's where the discussion is going. So I can give you some ideas of the discussions that are going on. So, for example, because I really want these discussions to be a little bit more efficient, in a way that I want people to define things a little bit more, so that otherwise you have like 100 messages that are for other people that comes, and then they want to have a look, and then they want to see what the discussion is about. Then they are not very useful, because this 100 message was just about something, and then we finally started to define, and then we realized it was useless or something like this. For example, here, Kenardo. Okay, is Kenardo here? Then he can help us. No. Hi, Osito Craft. Thank you for joining. Where is the X1? Soon, zombie. Okay, so here, for example, he started by, I'm not convinced there is much basis to the hypothesis of elastic shrinkage. Okay, so, okay, but what I think would be more efficient is to point out, what doesn't make sense in the elastic shrinkage theory. It's, for me, it's not very useful to say, yeah, but elastic shrinkage doesn't make sense, or yeah, but I don't think it's elastic shrinkage, or it's not very useful Okay, yeah, I mean, you share your opinion, great, but what we want is something useful, right? So here, when he say, I'm not convinced there is much basis to the hypothesis elastic shrinkage, I think it will be more useful for the PrintBuster community to define and point out what part of the theory doesn't make sense, and then we can continue working on it. Because that's what I asked him. You should ask him which part of the elastic shrinkage theory you do not understand. I may be able to explain more. Blah, 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 blah. Okay, like for example, the thermal shrinkage theory. I pointed out, I asked the question, why PLA and PC warps differently? Why if you use a heated bed, it's better? Why if you use a cooling fan, it's better or worse? So I point out, I ask question, but I don't say, I don't believe I don't believe in the thermal shrinkage theory. Internal stress still buildups in polymers in the rubbery in viscous flow state. Blah 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 blah. Okay, and then he talked about the difference between PLA and PC, and for him, the difference between PLA of PC is that the PLA will crystallize during the 3D printing process, which I highlighted after that it doesn't happen. PLA stay amorphous. Otherwise, if it would crystallize, then your PLA print out of the printer would have 140 or 100 plus degree heat resistance, which is not the case. So that's why it doesn't crystallize. And then he used a lot of words that I don't understand very much. So that's why he is going to try to find a different way of explaining. But for example, you see, what I like to do is I try to make things simple and ask a question. And usually, I wait for the answer. I don't add on top. Otherwise, things get mixed up so easily. Like, for example, here, I tried to answer his two things, but he didn't answer my question, which part of the elastic shrinkage he didn't understand. And then it's always like this in discussion, like we kind of forget questions if there is too many questions, and it loses efficiency, because if you miss that question, then all the discussion, the rest of the discussion sometimes doesn't make sense. We have to go back, we have to go slowly. The Discord Ponymaker still shows you do not have permission to send message on this channel. And US Rover, you still have this problem? Yeah, I don't know. Maybe it's a Discord problem, not our server, because there's nothing on our server. Or maybe Zombie can help here, but I don't know what's happening. I think I asked this in the Discord, but is PC still out of stock? No, it should not be. Well, depending on where you're based, right? Yeah, this is the same as definition, right? If you ask if something is in stock, then where, like in Canada, in Japan, in Australia. I mean, yes, maybe you have told me before where you're from, but maybe I forgot. So you can say, is Polymax PC Black 1.75 available in the US? Or is Polylight ABS Purple 2.85 3 kg available in Canada? I know it's a lot of detail in one question, but the more detail you put in the question, and the faster you're going to have the answer. Because now you're asking about PC. What can I do? I will go in I don't know which country, but let's say I go in the US, and then I check PC, but we have 30 SKUs, right? Maybe some SKUs are in stock and some are not in stock. So the best answer you're going to receive is an Excel file with all the different SKUs in all the different countries, and all the different, whether it's in stock or not. But I don't think you want this, right? Where is that Twitch stream? It's going to be on Saturday on Twitch. Okay, Griff. Yeah, but you do have to understand it is terribly difficult to explain over chat, typing sometimes, especially if we are trying to keep up with you while you're speaking. Yeah, Griff. So I'm talking about the Discord, right? So on Discord, we are both typing, right? So I'm not talking about the stream, because the stream I completely understand. I'm the one talking and you're the one writing, which is impossible to keep up with. I completely understand. But I'm more talking on Discord. On Discord, when we talk to each other, then we have to be structured, and then we have to define things properly. We have to give, like for example here, I still don't know which part of the elastic shrinkage he didn't understand. And I don't want people to come in and only talk about one theory. If you come to the warping topics, the first thing you need to do is to understand both theory as much as you can. And if you don't understand, then you start asking questions before trying to defend your own theory. That's my thinking. Because if you start defending, you don't even want to spend time understanding the other theory, and then you just focus on your theory and try to defend it. I don't think that's the right way to do. So I don't know. You see, for example, Kenardo is not convinced about the other theory. But how much does he know about the other theory? Did he even did some research on what is this theory? I tried to ask him, but he didn't come back to me on what part he didn't understand. So I don't know if it's because he really believes in the other one, so he doesn't want to spend time on the elastic shrinkage, or not. You could try slow mode the channel, make people think about what they send a little. Yeah. Oh, Kenardo is here. There you go. Hi, Kenardo. We're talking about our discussion on Discord. So what I just said is there is one part. There's one part where you said I'm not convinced. There's much basis to the hypothesis of elastic shrinkage, and what I was saying is the best is to always point out to what part you think doesn't make sense, or what part doesn't make sense, and then we can start the discussion. But I think after I think that the question was forgotten, and then I was saying that one of the explanation you gave about the fact that PLA and PC warp differently was because for you the coefficient of thermal expansion is not representative of what is actually going on during the 3D printing process. And then I said that I didn't understand that part, and then you said that you will come back to us with some other explanation. And basically we are reviewing our discussion because I think it was a great discussion. Okay, so the other thing, so he defined a little bit more the internal stress. Grith, I get that. For the thermal discussion we had in person, I think being able to talk in person made much easier for me to see which part you were understanding and which part you were not. Yes. Yeah. So like Grith said, feel free to always go on our Discord and jump in the voice channel, because it's always better to explain yourself, and maybe you have some PPT graph or some small drawing and stuff. So there is a channel that is called where's the voice channel here? That is called Talk Science. Maybe we should rename it PrintBuster or something like this. And in that channel, you can come in and then you can explain. Like, you don't have to write everything. You can really explain, and then the interaction will be much more efficient. So yeah, definitely agree. I completely agree. And I think the discussion we had on that channel, face to face, I mean, video to video, was much more efficient, and we actually came out with a great theory. I think the theory you point out is, for me, in terms of logical thinking, is better than the other thermal shrinkage. At least there is some explanation and things can be explained, rather than the other one you cannot. Got to go. Just good news for a neighbor passing. Thank you, Abdullah. See you on Saturday, hopefully, or next week. I'm not getting proper responsive to those matter. It's been a busy time at work lately. Yeah, definitely, Kenardo. Don't worry about that. Don't worry about that. Like I said, if you wanna go on a voice call, that's makes things easier. But definitely, I mean, the what you have been participating already is a lot, and I think the fact that you are challenging the CTE in 3D printing is a great point, and that's something that needs to be Oh, that's why you came. Okay. And so that's a challenge that you see. I wouldn't have challenged the CTE in 3D printing, but now that you're challenging it, then we need to do more research. Why in 3D printing would the CTE be different or not? So that's a good point. See you, Santiago. Will Polymaker do any product for resin printer? Not in the pipeline at the moment. Okay, so let me give you so that was for warping, and then let me give you a quick summary for the other one, which was flow calibration, right? To calibrate your printer. Let me check. Where is flow calibration? So for this one, nobody answered yet. I put my conclusion on that topic, and there's no answer at the moment. So I guess I don't know if it's because the conclusion is clear, so there's no more to talk about. But I will always try to finish a PrintBuster topic with a summary. Now it's a message, but I will try to write a document, and then I will just put it there. And then if someone one day want to re-challenge that, then he can go through the document and then point out exactly where we can. Well, we have one answer here, and then we can rediscuss that. So the conclusion I have for the flow calibration, and let me know if you wanna challenge that, right? I want to be clear that I'm totally open to any explanation of the phenomenon. I agree completely. We need more research. Yes, yeah, I agree. More research. What I was saying is, if there is anything you don't understand on the elastic shrinkage theory, feel free to ask. That one I'm more comfortable with. If you have question on the thermal shrinkage theory, then we will have to find out together, because I'm not that logically. Yeah, you get what I mean. So for the flow calibration, so the idea was the E step and the slicer flow was basically the same, right? And the conclusion is this one. The E step for the 3D printer is about how much the gear. So I define. Well, let me just read, okay? Because I write this down. So just writing down my own conclusion on the subject, which makes more sense for me. Blah, blah, blah. Let's take the average stepper motor, which has 200 steps, okay? Which means it takes 200 steps to do one rotation, right? And then I define the E step as the number of steps it takes to extrude 1 millimeter of filament, okay? Of 1.75 filament. So basically, 1.75 or 2.85. Actually, I shouldn't have wrote that, but it's how many steps does it take for a theoretical line that follows like this, okay? And 1 millimeter. So it's pretty easy, right? You take so the average diameter of the extruder is 11 millimeters. So let's say you take the diameter of your gear and it's 11 millimeter, and then you do your calculation. So one rotation, you are going to move 34.54 millimeter of that imaginary filament, right? So that means 200 divided by 34. So that's 5.79 steps per millimeter. Okay, so your E step is 5.79. But of course, it cannot take a half step or something like this, right? So I give an example. If you need to move 100 millimeter of filament, so the theoretical steps is 57.9. Okay, so sorry. Yeah, so the steps you are going to take is 579 steps for 100 millimeter of filament. So now your E-step is calibrated. That's it. That's the only thing you need to do. Okay? And then, so you don't have filament, you don't have material, you don't have anything. You just have the printer. Now your printer is calibrated. The E-step for me is calibrated. Now you add the filament in the system. Okay? So now that you have the filament and you extrude, you extrude the filaments, you want to extrude 10 millimeter or 100 millimeter, you will realize that it would be less, most likely less. And then you have to compensate this with the flow. So why wouldn't it be the same? So I wrote some factors that can be that can influence. So the main thing is the extruder is going to deform your filament. Okay? And the factors that can influence the deformation, the only thing that you need to compensate for is the deformation of the filament in the extruder. Nothing else. Deformation. And what can influence this deformation? Well, the tensor, right? How tense is the tensor? The gear sharpness, the nozzle pressure. If you have a lot of pressure, then the pressure from the nozzle that is required will come back to the extruder and then will create more shear. Then you will deform your filament more. The Bowden friction is also going to create some pressure and then will add more shear in your filament. And maybe there is some other factors that I haven't thought about, but it's all about the deformation of the filament that you need to compensate for. So in theory, the slicer flow will always be above 100%. If you follow my logic, it cannot be below 100%. In order to calibrate your slicer flow, you can extrude a certain volume and weight, okay, of filament of a set volumetric speed and nozzle temperature. Okay, so you have your printer, you have the tensor that is set, you have the volumetric speed that is set, you have the printing temperature that is set, everything is set, and then you run. And then you extrude a certain volume, and then you check the so volume or weight, and then you check. So we're not talking about forming filament. Maybe I should have put that here. Like we are not talking about density changed filament by the process. And then you check the volume and weight that you extruded, and then the volume and weight that you have, or like the theoretical thing that you extruded and what you have. And then you adjust your flow until it's the same. And then your slicer flow is calibrated for that temperature, for that volumetric speed, for that tension in the filament, for that Bowden tube. Then it's calibrated. Okay? And then that's it. So there is a downside. The retraction is apparently not taking in account, it doesn't take in account the extrusion multiplier. So that means if you retract, let's say 3 millimeter, it may be less, okay? Or you would have to calibrate your E-steps with a specific tensor tension, a specific gear, specific nozzle pressure, blah, 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 which doesn't make sense for me. So that's my conclusion on what is calibrating your E-step and what is calibrating your slicer flow and how do they work together and what are they dependent on. Okay, E-step is only dependent on the stepper motor, the gear size, that's it. Not material, nothing else. The slicer flow is only dependent on the material, whatever can deform the material, tensure or gear sharpness, blah, blah, blah. Okay, let me throw that. I calibrated my E-step perfectly and had to adjust Polytera to 90%. Oh, so below 100%. So when you say calibrated your E-step perfectly, do you mean which calibration? Because I know the calibration I'm talking about where you take the diameter of the gear, I think nobody does that. I think they all use filament, which I think doesn't make sense, but I can understand. Because otherwise you would have to recalibrate your E-step every time you change filament or every time you change nozzle pressure or something like this. Or some people don't use the hot end, but then you need to recalibrate every time you change the tensor, the tension on your tensor, or every time you change the filament, like TPU or something. So it makes sense in terms of logic, but it doesn't make sense in terms of you're not going to recalibrate your printer every time you change a filament. I think that doesn't make sense. So Zombie, what were you referring to? Distance calibration. Okay, so you're not, Do's Ali printer. Yeah, every filament I've tested seems to match the E-step. Okay, so you haven't done this one. So if you do what I suggested, then your flow cannot be below 100%. Greece, I still think we would need to talk to someone who has built printer firmware slicer for this argument. We don't know how E-step flow affect things like pressure advance, retraction, etc. We don't know how flow. Yeah, okay, yeah, we can confirm that. Actually, what we can do, I just had an idea. For PrintBusters, we can invite some people. I mean, there is there's a lot of printer manufacturers around here, right? So we can invite some engineers from these printer manufacturers, and then we can talk to them. We can prepare questions together on Discord or something. Like, for example, flow calibration. I think we went pretty far into the discussion, and now we have great questions. And then we can invite someone on stream, and then we can just ask him. We can ask this question. I mean, we can even send the question beforehand so that he has more data. He can prepare some stuff, and then we can check things together. That's a good idea. Yes, Mark UFO, exactly. That's that was exactly the idea. Some filament seems to over extrude. Zombie, some filament seems to over extrude. So it means sorry, I don't understand. Like if you push 10 millimeter of filament, then you have more than 10 millimeter that come out, or yeah, depending on how you calibrated your E-step. If you calibrated your E-step like I've mentioned here, then it shouldn't over extrude. It cannot actually. It cannot over extrude. Otherwise, that means you're pushing the filament, but the filament is going faster than the gear, because the theoretical filament that you have calculated in step 1 is the fastest one. It's like completely rigid filament, and then you just go, and then perfectly, like perfect friction between the gear and the filament, and then you just go. But you cannot have a filament that go faster, or the filament is out of specs. That's a different story. Maybe you put in your slicer that it was 1.75, but in reality is 1.8, for example, or 1.77. Then that would explain. But our filament are good. Our filament are good quality, right? So you won't have that issue, right? If it's 1.75, then it's 1.75. It could have a plus minus something. To get a good surface finish, I usually have to decrease the flow. For this one, I agree. And I don't know why, but I used to do that also. I somehow, especially when I was printing in the Ultimaker, I sometimes, if I put 90%, 95%, or slightly lower, I get better quality. I don't know why, but that was the case. But at that time, I was not into this calibration stuff, so I have no idea what was the E-step. I have no idea whether the flow was calibrated, whether I had the necessary volume coming out, etc., etc. I don't know. So we should check that. Okay, so anyway, that's the summary of this one. And if you have anything to say, anything to suggest, feel free to go in for calibration and rewrite, like ask some question or something, and then I can modify that conclusion. By the way, your PTG profile on your website is set to 200 millimeter infill, way too high. Oh, okay. Yeah, those are very, very old profile. We may need to upgrade them. And there might be some typos also. Okay, and the last one is food safety. Same here. My rotation distance in Clipper is pretty spot on. And I have my flow at 90% for layers after the first for PLA Pro. Yeah, again, try to see what's happening. Like when you say rotation distance, so I guess you have calibrated in the way that I suggested, right? You take the diameter of the gear and then the theoretical 1 millimeter extrusion equal how many steps, right? And if you do that and your flow is 90%, which means you ask the slicer is asking to extrude 1 millimeter cube, but you extrude less. And somehow this less is better quality, but it's still less. So my question is the slicer good, right? If the slicer is good, then theoretically it should extrude exactly what you need for the perfect print. 0.4, 0.2. You have pressure advance so that it extrude at the right time and you know it doesn't over extrude at the end or under extrude at the beginning. So everything, if it's calibrated, everything should be fine. So now the question is, why do we change this flow and stuff? That's the part I would like to answer. You know, if you calibrate like I suggested, right? You have your E-step is calibrated, your slicer flow is calibrated and per temperature, and somehow if Clipper can do that or if Cura can do that, depending on the speed or the volumetric speed, then the flow will change a little bit because the shear stress will be different on the filament. So if you have these calibrated, then why should we change other stuff? You know, is that the slicer that is not good enough? You know, the slicer makes some calculation, but they are not good enough, so you have to retinker that on top of that, or what? Or is it because what I just said, the slicer flow depend on the temperature? Okay, so but I don't think slicer can handle that. The flow is whatever the temperature, but we already know that the infill is printing pretty fast compared to the outer shell, right? So maybe when you print the infill, you have to increase a little bit the flow to compensate for the shear stress in the extruder, but it doesn't do that. But somehow you compensate that by changing the flow manually or something like this. But the question is, why, if your printer and slicer are calibrated, why do you need to touch anything after that? Gris, I know Polymaker has some print profile. Maybe you should go through some of them. I know Polytera seems to be very different from a lot of PLA from it. We will do that. We will I think we should remove this print profile for now and then put our new one because these are very old. I was just curious to see how they would work. It was actually crazy impressive see the PTG channel. Poilite PTG? Or I guess Poilite PTG, right? Yeah, sorry. I don't have internet good enough to see your picture. So if you want to see the picture, then you have to go on Discord yourself. And then you can check yourself. But I cannot load the picture. Oh, there you go. It's loading. One by one, slowly. But in terms, I mean, you can tinker around, right? You can. Oh, there you go. Because there is the theory and there is, the experiment. The idea is to have a theory, to experiment, to have some result, and then what most people don't do is going back to the theory. You get what I mean? So you calibrate everything according to a theory, it's fine, and then you do experiment, it doesn't work very well, you change your flow, now it's working very well, then that's it. Most of the people stop there. But PrintBuster come back and then say, okay, we changed the flow, it's now working better. Then we come back. Why? What's wrong with the theory? Okay, that's the idea. I went by clipper documentation. So if I ask the printer to extrude 50 millimeter, it extrude close to 50 millimeter from the inlet. If I ask the printer to extrude 50 millimeter, it extrude. So sorry, what does clipper documentation say? Does it say because it extrude 50 millimeter doesn't, can we have something that is a little bit more, something like if you extrude 50 millimeter, it's going to rotate 50 times E-step. Then great. Does it have something like this? That would make more sense, right? Every time you ask a certain millimeter of filament, it's going to do this millimeter of filament times E-step, and then it's going to send the information to the stepper to rotate that number of step at a certain feed rate. Do we have that? Yeah, Cura 5, a lot of people has issue with Cura 5.0. I don't know why. But usually that's the case, right? When you have a big upgrade like 4.0 or a 5.0, then you will have issues until 4.0.1, 4.1, 5.0.1, 5.1. So that's normal with big upgrade. There is always some bugs. Extrusion distance is 99.9% accurate. Flow seems to modify other aspect of the print. Flow seems to modify other aspect of the print. Yeah, sorry, I'm not sure I understand. Like what I know is, like, for example, the CNC kitchen test is perfect to calibrate your flow. You test different temperature and different stuff, and you extrude a certain weight, and then you check the weight, and then you adjust the flow until it's dead flat. At 190, you have exactly that gram, and then so if your flow is calibrated like this, let's say you extrude at 190 degree, your PLA, you extrude 10 gram, 1 gram, and then you check, and then you have 1 gram, then it did the job, right? So if you print at that temperature, at that volumetric speed, then it should be perfect. And if it's not, if the surface quality is not good or something, then it means it's extruding the right amount, but that right amount is not right for a good print, if that makes sense. The slicer cannot account for the difference in filament from brand to brand and product to product. Yeah. Yeah, so that's why I don't think we should put the material in the E-step calibration. But the flow calibration you could. Because every time you use a new filament, then that there is like the X1, right? It calibrates automatically every time before the print, which I think is very smart. But if you would have to do that, like, I would be very interesting, the X1, I'm pretty sure the X1, that's how they calibrate their E-step. They just use the diameter of the gear. I think they don't care about the material. And they use the flow in order to calibrate with the material and the temperature and stuff, I guess. I would 100% remove them if they are not updated. Yeah, I mean, they are working. There might be some typo. I mean, if we put them, then it means they're working. But, I mean, that doesn't mean they don't have typo. But the fact that we did that a long time ago, then we haven't reviewed whether there is typo or something, and we haven't received much feedback. I think not a lot of people use these profiles. What I meant is they were designed in old slicers, so there could be some compatibility issue. There could be a lot of other issues. I noticed that when I slice and send to my printer, my flow is automatically at 95%. Is it because of the slicer? I don't think so. Everything plus ultra. If you're talking about 95% on the printer, then it's most likely because there is the slicer flow and there is the printer firmware flow. So like the slicer flow can be 110, but on the printer, when you go and check flow, it's 100%. But it's 100% of the slicer flow, which was 110%. And then you can change that. Maybe your printer somehow used 95%. I don't know why. But it should be 95%. It means 95% of the flow of your slicer. So if it was, I don't know, 200% in your slicer, then you take 95% of that 200%, which is 190%. Maker, your E-step in Clipper is rotation distance. You generally set rotation distance and then calibrate to make sure you've gotten the calculation correct. Okay, so what you're saying is E-step. So I define E-step by the number of steps it takes to extrude 1 millimeter. And what you're saying is on Clipper, E-step is defined by what? Your E-step is in Clipper is rotation distance. You generally set rotation distance. So, okay, so what is rotation distance? Rotation. Oh, so you mean E-step is defined by the distance the stepper motor would extrude if it does one rotation. So E-step is not even the number of steps. Is the distance of the filament, right? Or rotation distance, yeah. So the E-step is the perimeter of your gear. That's how it's defined in Clipper. Which is strange, no? If it's E-step, it should be the number of steps, no? Not the extruded amount. I don't know. It's based on the gear ratio of stepper. There's extruded gear. If a 0.4 nozzle is really 0.1, then you will over extrude. No. Zombie. If a 0.4 nozzle in reality is 0.42, then you will over extrude. I don't think so. If the slicer say extrude 1 millimeter cube of filament, whatever the nozzle size is going to be 1 millimeter cube, because it will calculate this with the nozzle size you put in the slicer. So whatever it is in real, it will still extrude the same amount, theoretically. Where was I? I think that's the case. The slicer is not smart enough to know exactly how much distance it takes to get a perfect real-world result. I'm using a Sherpa, blah, blah, blah. Rotation distance is the same thing as E-step. Yeah, so maybe I need to wait for Grieth's answer about that. Clipper rotation distance is the amount of distance that the axis move with one full revolution of the stepper motor. Yeah, okay. But then I think it's strange. Why do they call that E-step then? Because it's not even a number of steps. So why would they call it E-step? My rotation distance is rotation distance. Yeah, I mean, if you're talking about rotation distance, then I think it makes sense. Is the distance for one rotation. I think it's fine. And that is calculated with the perimeter of your gear, which I think makes sense. Stepper motor drivers on Clipper requires a rotation distance parameter in each stepper configuration. The rotation distance is the amount of distance that the axis move with one full revolution of the stepper motor. The document describes how one can configure this. Yes, this yes. Okay, so how do they configure this value? Do they do what I suggested? They take the diameter of the gear and then that's it. Basically, the rotation distance is the perimeter of the gear, right? Because one rotation of the gear means the thing will move like one perimeter. Okay, so diameter times pi, and that gives you the rotation distance. On the extruder, the amount of distance the filament travels for one full rotation of the stepper motor. Yes, it's not called E-step in Clipper at all. It's called rotation distance. It's the amount of distance that the axis move with one full revolution of stepper motor. Okay, got it. Yeah, sorry. So I thought they called this E-step. Yeah, so if it's rotation distance, then okay. Then that's fine, right? Here's the formula. Distance, rotation distance, full steps per rotation times microsteps divided by steps per millimeter. Full step per rotation. So 200, right? So you do 200 step for rotation times microstep. I don't know what is microstep. Divide by steps per millimeter. Steps per millimeter. I don't understand. Can you, Bear Squad, can you replace this by real number? Like full step per rotation, like 200? That's the average steps for a stepper motor, right? Like usually it's 200 step per rotation. And step per millimeter, steps per, so how many step per millimeter? Which means for 11 millimeter diameter gear, it should be 34.54, right? So you do 200 multiply by whatever is microstep, divide by 34.54. The slicer uses algorithm to define an amount to extrude. However, we need to tweak this based on material properties and how a given print look. Material properties, Luke Ingerman, I'm not sure, because you should have calibrated your flow according to material properties. But the print look, yeah, that's your choice, right? If you prefer your print to be under extruded, then you under extrude. If you prefer to be over extruded, then you over extruded. How do we get those numbers for the formula? Yeah, I think it's this. I guess the full step per rotation means, you know, the basically the accuracy of your stepper motor, right? How many steps does it take to do a full rotation? I guess that's the meaning of full steps per rotation. So I guess it's 200. I mean, depending on your stepper motor. Microstep, I have no idea what is that. And steps per millimeter means how many steps do you need to do to extrude 1 millimeter. So in the case of 200 step stepper motor with a 11 millimeter gear, then it's 34.54 steps. No, sorry, 5.79 steps. Sorry. So it takes 5.79 steps, theoretical steps, to extrude 1 millimeter. I posted the descriptive link in the Discord flow calibration. Okay, great. So let's go. I always wanted to do a Clipper stream. I think a lot of people talk about Clipper, so I would love to talk about Clipper. What? Copy message. Yes, check. 400 steps gone. Okay, yeah, it depends on your stepper motor, right? I'm working on a diagram explaining anisotropy. I'm going to mute the stream so I can concentrate on it. I'll ping back. Okay, great. Thank you, Kinardo. Okay, rotation distance, 200 times 16. This part is different for everyone. But why would it be different, the other one? Microstep is how fine of a resolution the motor can go. Typically is 16. Oh, so you mean 200 is the number of step, and in between step, it can do 16 microsteps? Oh, I didn't know that. I thought 200 was the accuracy. Like cannot go in between. Then why we don't directly say 3,200 steps? Why there is a big step and small step? Is the small step a little bit less accurate than a full step? I wish I switched to Clipper right after getting my printer. Wasted too much time messing with Marlin. Okay, rotation distance. I love this kind of document. Stepper motor driver on Clipper requires a rotation distance parameter in each stepper config. What is this? The rotation distance is the amount of distance that the axis move with one full revolution of the stepper motor. Okay, this document describes how one can configure this value. Okay. And the designers of your 3D printer originally calculated step per millimeter for a rotation distance. If you know the step per millimeter, then it is possible to use this general formula to obtain that original rotation distance. Yeah, but that doesn't really help, right? Because we don't know. The designers of your 3D printer originally calculated step per millimeter. So I guess it's this. I guess the step per millimeter is the calculation we've done before. It's the perimeter. You know how, like the perimeter divide by the perimeter in millimeter, the number of step for a full rotation divide by the perimeter in millimeter, and that gives you the step per millimeter. But let's see if they explain. Rotation distance is the full step, micro step divided by step per millimeter. Or if you have an older Clipper configuration and know the step distance parameter, you can, I don't know what's the step distance. The full step per rotation setting is defined from the type of stepper motor. Most stepper motor are 1.8 degrees, therefore. Okay, so this one we got it. Okay, 200 step. Some stepper, blah, blah, 400, blah, blah. Okay, the micro step setting is defined by the stepper motor driver. Most driver use 16 micro step. Okay. Yeah, I still don't understand what's the difference between full step and micro step, but I understand. So you have 200 big step, and each of the step can be re-divided in 16 steps. So you have to multiply 200 by 16 in order to have the full accuracy of the stepper motor. Almost all printers should have a whole number for rotation distance. If the above formula results in rotation within 0.01 of the whole number, then round define a variable. Okay, so how do we calibrate that? On the extruder, the rotation distance is the amount of distance the filament travels for one full rotation of the stepper motor. The best way to get an accurate value for this setting is to use a measure and trim procedure. First, start with an initial guess of the rotation distance. This may be obtained from stepper motor or by inspecting the hardware. Okay, so I cannot know how it's going. My guess is inspecting the hardware, they are going to take the diameter of the gear, something like this. Yeah, you see, rotation distance is the diameter times pi. And then they are going to use that as a base, and then they are going to recalibrate it depending on the filament. That's my guess, which I said doesn't make sense, because then you have to recalibrate every time with new filament, new stuff, new tension, new gear, if it's worn out or something. Then use the following process. Well, if it's worn out, then you also need to recalibrate for the diameter. Make the measure the extruder has a filament in it. The hot end is heated to an appropriate temperature. Yeah, I disagree. I don't think we should do this way. Extrude 50 millimeter of filament, blah, blah, blah. I mean, maybe it's the best way, in a way that it will give you the most accurate, because of the retraction and stuff that doesn't take into account the flow, so you wouldn't be able to recompensate it in the flow. But I don't think it's the right way to do, in a way that it's not accurate. It's the most accurate you can do, but it will never be 100% accurate, because if you change, can you imagine you change filament? Like when you print TPU, you have to recalibrate your firmware rotation distance. It doesn't make sense. What do you think? I mean, I know I'm talking about Clipper, so I'm sorry if I'm saying this. I know you guys love Clipper, but I don't know. It feels very strange that they put the material in the firmware calibration. I wish I switched to Clipper. 200 is the physical design. You can force it. Okay, 200 is the physical design, and you can force it to go finer. Okay, got it. So 200 is like a very accurate step, and then the 60 micro step is not that accurate. Kind of. It becomes less accurate the more micro step you go. Yes, okay. 200 is a step. 16 micro step means 16 step in each full step. Okay, yeah. Micro stepping has lower accuracy and torque. Oh yeah, torque also. Yeah, that's a good point, Josia. Oh, Josia, thank you for joining. Doesn't the motor microstep change for each motor? Most likely, I guess. Accurate enough. Scroll down to calibration for extruder. Okay. Yeah, I guess that was this one, right? Hardware is physical gearing. Yeah. So for me, this is what we should do. We should stop here. You know what I explain here? This is exactly, this is what I wrote here, right? Here is this. So for me, we should stop here. We shouldn't continue here, because what they say is first start with an initial guess for the rotation distance. This may be obtained with blah, blah, blah. Then use the following procedure. So first, check the theoretical rotation distance. Then calibrate that rotation distance according to your filament and hot end. I just gave you a summary of what Clipper is saying. Clipper is saying, first get the theoretical rotation distance, then calibrate that rotation distance according to your material and your hot end. And what I'm saying is, I don't think you should calibrate. I think the flow slicer should be the one that compensates for any change depending on the material. Otherwise, and my argument is, otherwise, every time you change filament, you would have to recalibrate the firmware, which is not ideal. For TPU, you can also adjust the flow multiplier. Yeah, but that's not what Clipper say. Clipper say, if you change material, you go back to your firmware calibration and you recalibrate your rotation distance. So if you use TPU 90, TPU 95, 95 HF, ABS, PLA, PC, very, very hard, then you go back to your Clipper calibration. Okay, benefit number one of Clipper: updating firmware can be done from a cell phone computer with like 4 keystroke and 2 click. Yeah, I mean, yeah, if it's easy to calibrate, then I guess no problem. If you can change the rotation distance by easily, then I guess that solves the problem also. Clipper modifying anything in the firmware is just editing the printer CFG, takes 2 minutes and restart. Okay. But then all the arguments from the people on Twitter is doesn't work, right? Because all the argument was based on the slicer flow is easier to change than the firmware. Then now we end up by saying that the firmware is as easy as the slicer flow. I tried Clipper. I just wasn't patiently enough to calibrate it and disliked not having a physical LCD. Polymaker, the E-step rotation distance is provided with the extruder. Yeah, I mean, of course, because it has nothing to do with material and stuff. But not the rotation distance from Clipper. There is the other rotation distance, which is the theoretical, which is this one. It's possible to obtain an initial rotation distance for extruder by measuring the diameter of the, and that's also why I don't like using the same vocabulary for things that are completely different. In Clipper, they use rotation distance for both the ideal one and the material dependent one. Or maybe I guess their vocabulary is initial rotation distance means not material dependent, and rotation distance means material dependent. If the extruder uses gears, then it will always be necessary to define and set the gear ratio for the extruder. Yeah. The actual rotation distance. Okay, so they have initial rotation distance and actual rotation distance. On the extruder will vary from printer to printer because the grip of the hub bolt that engage the filament can vary. It can even vary between filament spools. After obtaining the initial rotation distance, use measure and trim procedure to obtain a more accurate setting. Okay, so now that's very clear, right? On Clipper, the rotation distance, the E step, is calibrated according to your material and your printer setup. Okay, so all what I said. Oh, but now, there you go. Now is the question. Why do you need the slicer flow? Do you need to calibrate your slicer flow if you have taken everything in account? So Clipper user, because I think we have a lot of Clipper user. If you have followed the Clipper documentation, it means your rotation distance is calibrated for your filament, for your hot end, for your tensioner, for your printer setup, right? So now there's nothing to do with the flow. Is that correct? You don't have to change anything. It's already calibrated. I use Prusa firmware, basically Marlin. I just adjust the flow multiplier, but each require a different flow for a good surface finish, blah, blah. Yes, they provide that value. You use that as a baseline, then calibrate it using 100 millimeter method, depending on the extruder tension and the material used. Okay. Great example for need of flow, setting Polytera flow to 90% for better surface and it not messing with retraction in unknown ways. Yeah, Griff. So now the question is why you need to use 90%. Does that mean the slicer is not good? The slicer is extruding exactly what you need. 0.4, it should be very smooth surface. Everything should be perfect. Why we need to change the flow? Is it the slicer is over extruding and it makes the print looks bad? Bear Squad, yes. So you answer yes with the question I ask is you don't have to change the slicer flow, right? Wait, do you also use 90% for Polytera? Okay, so I think it's pretty clear. So Clipper user, if you print with TPU, so you're redoing this, right? And then you change your rotation distance. No idea why the need of 90%. You guys were saying that. No, what I was saying is I also noticed that if you use a lower extrusion multiplier, you get a better result. But I don't know why. Theoretically, we should not. All I do is to run the flow calibration test and pick the best surface finish. Yeah, but then it's a different calibration. It's based on surface finish. It's not based on making sure. It's not, for me, it's not a calibration. A calibration is about asking something and you calibrate in order to receive that something in reality. But now your calibration is about asking something and get a good surface finish, which I think is strange. I think he didn't calibrate his rotation for Polytera. I think so too. If you do what Clipper asks, then you should not change your flow. And if you change your flow, it means the slicer the slicer is not good. It doesn't provide a good G code for a good print. For Polytera, I have 100% flow. For Polylite, I have set to 94%. Yeah, I mean, Polytera is softer than Polylite PLA. So most likely, it dive more into the Polytera. It chew the Polytera more, so it's 100%. So it chew less Polylite PLA, so it's lower. But again, you are not following what Clipper is asking, which is each filament has to have their own firmware rotation distance, not slicer flow. So from Clipper, your slicer flow is almost useless. Not almost, it is useless. And the issue is, the issue is you also take in consideration the temperature, the hot end temperature, and the pressure. But that change I really think it doesn't make sense, because all of this change during the printing. The shear stress on the filament changes. So it should be controlled by the slicer. It shouldn't be controlled by the firmware. Make sure the extruder has filament in it. The hot end is heated to an appropriate temperature and the printer is ready to extrude. What's an appropriate temperature? Use a marker to place a mark on the filament around 70, blah, blah, blah. Then use the digital caliper to measure the distance, actual mark precisely, blah, blah, blah. Extrude 50 millimeter filament with the following command sequence. Not 50 millimeter. Wait the extruder to finish the move. It will take about 50 seconds. It is important to use the slow extrusion rate for this test, as the fast rate can cause high pressure in the extruder, which will screw the result. Yeah, exactly. But when you print, you don't print at a slow rate. So what's the point of calibrating? Do not use the extrude button on graphical front end for this test, as they extrude at a fast rate. Yeah, but that's how you print. So you should... It makes so much nonsense to me. It's not a calibration. I mean, you're not going to print at a slow rate just because you have calibrated at a slow rate. Use the digital caliper to measure the distance between the extruder body and the mark on the filament, blah, blah, blah. Then calculate, blah, blah, calculate rotation distance, round. If the extrude distance differ from requested by 1 or 2 millimeters, it's a good idea to perform the steps above a second time. Do not use a measure and trim type method to calibrate XY type axis. The measure and trim method is not accurate enough for those axes and will likely lead to a worse configuration. Instead, those axes and measure belt pulley. Yeah, actually in the next stream, because it's getting late, but in the next stream we should, if they do this for the E step, then I cannot even imagine what they do for the X, Y, and Z. But apparently they don't mind using a non-accurate one for the E step and an accurate one for X, Y, and Z. Why not using an accurate one for all of them? I mean, well, let's go back to this one. This step 3 doesn't make sense for me. It's not a calibration. Hey, my tech fan. Thank you for joining. We're talking about flow calibration here. Hey, good night, Grace. We're gonna finish in a few minutes. I'm gonna draw the winner and then we'll finish that. It's been exactly 2 hours now. So I'm just going back to the comments on that, and then we'll finish. Blah blah. Okay. All I do is run the full calibration test. Blah blah. I think didn't calibrate. Polytera. Blah blah. Okay. That's the big question. All my test print with E-step calibrated produce the same 0.4 volts for all materials. Okay. Giveaway soon. Yeah. We're in 5 minutes. 5 minutes. Who cares about clipper math? Just do a slicer flow. Clipper rotation distance and step are the same thing. Yes. Blah blah. Okay. I usually heat my extruder up to the maximum listed temperature on the filaments. Yeah, but again, I don't think it makes much sense to calibrate in this way. Builders Mark Nick, I picked up a manual filament splicer today. I actually just posted a tweet about it a few minutes ago. Splicing Polytera. Oh, you splice Polytera and Polylite? Okay, I'm going to check that. That could honestly be the explanation. The flow takes actual speed into account. Yeah, but in this case, Zombie, in this case, then I wouldn't even bother doing this for the firmware. If in any case the flow is going to be adjusted, because the speed is never going to be the one you use for the calibration. So what's the point of calibrating the firmware? I mean, to be honest, I really think it doesn't make sense. That there's no point. Especially now that you are telling me that you think that in any case, the slicer flow will override that calibration by doing a speed calibration. Then why not doing it directly, right? There's no point of doing this. We already have the initial rotation distance, which is the theoretical one. That's good enough. And then once you have that, which is not material dependent, so you don't have to change it per TPU, per something, and then you go in your slicer, and then you run your slicer, the slicer flow test. For example, the CNC kitchen test or something. And then that's it. It's done. Calibrate your E-step with no nozzle. That's what Neuro recommends. What? Well, that's not what Clipper recommend. And even if you calibrate with no nozzle, you still have material dependent. So I still think it doesn't make sense. Or I still think it's not the most efficient way to do that. The slicer flow should deal with the material, not the... You see, actually, you know what? Even Neuro say the E-step is hardware related, and the flow is to compensate for the material. So even Neuro said it. So I don't think you should put any material in the calibration. Okay, I'm almost there. I guess the clipper method is to get the effective diameter for the extruder gear. What's the effective diameter? Do you mean that the diameter of the gear is different from... E-step are calibrated so all profile can work it interchangeably. Yeah, but how? Calibrated how? Calibrated how I suggested, which is only taking account the hardware. You should be able to download the profile for my printer and it should work with that filament. Yeah, but that's impossible in theory. What TPU is the hardest, 95 or 90? 95. 95 is the hardest. Okay, so I caught up on the chat. Let's continue this in the next PrintBusters show. I think there was a very good discussion. I think we learned a lot of things, and then finally I get to dive a little bit into Clipper. That was only one sub article of a definition. But I'm very happy that I finally dive into Clipper. I've heard so much about it. The Voron also. I'm very happy that we've learned about the Core XY, what it is, what's the advantage, what are the disadvantage. I'm very happy to dive into let me put that again. Our slogan, right? By the way, you still didn't tell me what you think about our slogan. PrintBusters, take a deep dive into 3D printing. Or should I say, take a deep dive into the science of 3D printing? Or maybe that's too long, right? PrintBuster, take a deep dive into 3D printing science, or something like this. What do you think? But okay, let's do the giveaway, and then we'll have a very good stream. I'm very happy with the stream we had today. It's exactly what I'm looking for PrintBusters. Really, taking a deep dive into 3D printing. Diving deep into tech deep dive into printer C. Take a deep dive. Dive deep into 3D printing science. Yeah, this I wish we have the science inside. Dive into the science of printing. Oh, Builder's Mark, that's not bad. This one. Let me update. So what else do we have? Let me edit. What did you say again? Builder's Mark. Dive into the science of. I think I would still put 3D printing. Dive into the science of 3D printing. Dive into the science of 3D printing. PrintBusters. Dive deep into. Oh, wait. I forgot something. Wait. Dive into the science of 3D printing. Yeah, I like that one. What do you think? Building our 3D printing knowledge one layer at a time. Yeah, I like that. That's a t-shirt. I just screenshot Greece. Good one. Build our 3D printing knowledge one layer at a time. Yeah, that's nice. Let me put. Dive into the science of 3D printing. And then I will put another one. Building our printing knowledge one layer at a time. Okay, perfect. Okay, great. So PrintBusters, dive into the science of 3D printing. That's perfect. Okay, guys, let's do the drawing. So is Mark Andraka here? I hope not. I haven't heard from him too much, so hopefully not. Then you have more chance. The only difference between messing around and science is 3D printing the result. It's 3D printing the result. If Mandraka wins tonight, it is fixed. Yeah. Like, to be honest, if he wins again, I'm going to check, this giveaway lottery. There's something wrong. Oh, he's here. Oh, I'm sorry, guys. He's here. Okay, you ready? I'm going to draw into 5, 3, 4, 2, 1. Drawing. Mark Andraka. Let's see. Oh, I thought it started by Mark. I thought it would be. I was scared for a minute. But it looks like you guys should be called Mark. Builders Mark Andraka, Mark UFU. Change all your YouTube name by Mark, and then you're gonna be in the special Mark giveaway. Mark from Utah. Yeah, whatever, Mark. Change all your name by Mark, and then looks like you have a better chance. So congratulations, Mark UFU. Here's my email. I think you have it already, but here's my email. Finally, not you, but it's still Mark. I still think there is something going on. Okay, congratulations again, Mark. Please contact me. I'm gonna send you a form for you to choose the spool. So, yeah, again, I'm back to the studio, so I have a lot of things to break. Maybe next time we should break some stuff. I have PS6 GF. I have Polymax PC. Have PA12. I have some ABS. I have PS6, CF, ABS. I have some ASA, some PC ABS. I have PC PBT. I have Polylight PC. Oh, the last time we broke that was quite dangerous. Okay, so we're good. Yeah, I know. I will try to save the plant. It's just the whole lockdown has been there. Okay, thank you guys. Thank you for joining again. My Tech Fun. I'm gonna definitely get some safety glasses for especially for the Polylight PC. So thank you everyone for joining our first episode of PrintBusters. And don't forget, all the discussion are still going on Discord. If you want to jump on a voice call in order to explain your ideas better, and then ask some other question, then feel free to join us there. Where usually I can connect usually in my evening, which is your morning, I think, usually. Okay, thank you everyone for joining, and I see you either Saturday for the Polymaker Hangout, either Tuesday for the Polymaker Q&A, or next week, next Thursday for the second episode of PrintBusters. And then we're going to continue all our awesome topics. Thank you, and I see you in the next one.